Hello everyone, welcome to video lecture of ME312 Metrology and Instrumentation. I am Manu Joseph, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. Module number 6, lecture number 3. In lecture number 2, we discussed about temperature measurement using instruments like liquid in glass thermometer, bimetallic strip thermometer, pressure thermometer and thermocouple. In this lecture, we are going to discuss about the temperature measurement using some other instruments like resistance temperature detectors RTD, thermistors and pyrometers. First, resistance temperature detectors. And an RTD is a temperature sensor that work on the principle that resistance of electrically conducting material is proportional to temperature to which they are exposed. The resistance of metal increases with the increase in temperature, hence the metal can be classified as the positive temperature coefficient. We know the material resistance varies with the change in temperature, and also for metal this change in resistance will be positive for increasing temperature. That is the principle behind RTD. The platinum is extensively used in high accuracy resistance thermometer because it is capable of withstanding high temperature, and at the same time they can sustain excellent stability and exhibit good linearity. When temperature measurement is performed by a resistance thermometer using metallic conductor, it is called resistance temperature detectors RTD. On the other hand, semiconductors used for temperature measurement are called thermistors. So, thermistors and RTD. RTD metals are used where the temperature increases, the resistance increases. But in thermistors, semiconductors are used where as the temperature increases, resistance reduces. The range of RTD is between 200 and 650 degrees Celsius. Many materials are commonly used for making resistance thermometers such as platinum, nickel, copper, which are contained in a bulb. The platinum is the most popular and internationally preferred material. When platinum is employed in RTD, they are sometimes termed as platinum resistance thermometers. Instead of RTD, they can be called as platinum resistance thermometers. The popularity of platinum is due to following factors. Due to these factors, this platinum is extensively used in resistance thermometers. The chemical inertness, one is chemical inertness, they are inert in nature. Almost linear relationship between temperature and resistance. The platinum having linear relationship, that is resistance is almost proportional to temperature. The large temperature coefficient of resistance resulting in readily measurable values of resistance change due to variation in temperature. Large temperature coefficient of resistance, that is one of the peculiarity of platinum. The greatest stability because the temperature resistance remain constant over long period of time. Greatest stability. Selection of suitable material for RTD element depend on the following criteria. The material should be ductile so that it can be formed into small wires. So RTD we are using thin wires and it can be coiled or drawn to small wires. So material should be ductile. It should have linear temperature versus resistance graph. It must resist corrosion. It should be inexpensive. It should possess greatest stability and sensitivity. It must have good reproducibility. These are the peculiarity of the material that to be used for RTD. Then the RTD has the following advantages. The resistance versus temperature linearity characteristics of RTD are higher. They possess greater accuracy, high as 0.1 degrees Celsius. The standard platinum resistance thermometer have ultra high accuracy of around 0.0001 degrees Celsius. They have excellent stability over time. The temperature sensitive resistance element can be replaced easily. That is another advantage of RTD. RTD show high flexibility with respect to choice of measuring equipment, interchangeability of elements, and assembly of component. RTD is flexible because its element can be interchanged, can be substituted, etc. Multiple resistance element can be used in the instrument. RTD have a wide working range without any loss of accuracy, and at the same time can be employed for small range also. Some of the disadvantages of RTD: the use of platinum in RTD make them more expensive than other temperature sensors. The nominal resistance is low for a given size, and the change in resistance is much smaller than the other temperature sensors. These are the disadvantages of RTD. Then general construction of a resistance thermometer. It comprises a number of turns of resistance wire wrapped around a solid silver core. We can see the resistance element. So you can see the RTD construction. Here we can see number of resistance elements, wires, and a central core is there. Then we can see a conducting flange, then a sensitive capsule, and a platinum lead. So that's about the construction. It comprises a number of turns of resistance wires wrapped around a solid silver core. The transmission of heat takes place quickly from the end flange through core to the winding. So that is RTD, resistance temperature detector. Now we are moving to thermistors. The semiconductors that are used for measure temperature is called thermistors. Here we are using semiconductor for temperature measurement. Here in RTD we are using metals, where temperature, as the temperature increases, resistance increases. Here it's different. Semiconductors are used where as the temperature increases, resistance reduces. When thermistors is employed for temperature measurement, its resistance decreases with increase in temperature. The material used in thermistors for temperature measurement have very high temperature coefficient, 8 to 10 times higher than platinum and copper, that is metal, and high resistivity, higher than any pure metal. Thus, they are very sensitive to small variation in temperature and respond very quickly. The temperature coefficient of platinum at 25 degrees Celsius is plus 0.036 per Kelvin, and for thermistor it's generally around minus 0.045 per Kelvin, which is more than 10 times sensitive when compared to platinum. So this platinum, compared to platinum, thermistors are more sensitive, or more compared to RTD, thermistors are more sensitive. The germanium containing precise proportion of arsenic, gallium, or antimony is most preferred for thermistor semiconductor material. That is the material used for thermistor semiconductor. The temperature measurement range of thermistor is minus 250 to 650 degree Celsius. That is the range. Then advantages of thermistors. Thermistors possess very high sensitivity, which is much higher than that of RTDs and the thermocouples, and hence have the capability to detect very small change in temperature. The response is very fast, and hence they are employed for precise control of temperature. They are inexpensive too. These are the advantages of thermistors. some disadvantages. They have highly non-linear resistance temperature characteristics. The temperature range is narrow. Low fragility is often problem. High temperature performance of thermistors is not good and they exhibit instability with time. They are prone to self-heating errors. These are the disadvantages of thermistors. The advantages are their sensitivity is higher than RTDs and thermocouple. The response is very fast. They are inexpensive. But there are certain disadvantages. Their resistance temperature relationship is non-linear. The temperature range is narrow. Low fragility. High temperature performance of thermistors is not good and prone to self-heating errors. The image shows different types of thermistors. Thermistors in the form of wafers, C2E, rods, beads, disc, etc. Now we are moving to another type of temperature measuring instrument, which is called pyrometer or pyrometry. When temperature of very hot body has to be measured, contact type temperature measurement device will not be suitable because they are liable to be damaged when they comes in contact with the hot body. Hence, the use of non-contact type temperature measuring devices become imperative. These non-contact type devices are called pyrometer. All the temperature measuring devices we have seen are contact type. Liquid in glass thermometer, pressure thermometer, thermocouples, bimetallic, then RTDs, thermistor, they all are contact type. The material, this thermocouple should make, or the temperature detectors should make a contact with the body whose temperature is to be measured. But here by pyrometry, we can do the temperature measurement without having any contact. The term pyrometer is of Greek origin, where pyro stands for fire and metron means to measure. The measurement of temperature are carried out either by measuring energy radiated by the hot body or by color comparison. The pyrometers are classified into two distinct categories. One is total radiation pyrometer and optical pyrometer. So, the principle behind the temperature measurement in pyrometry are of two types. One is energy radiated by a hot body is compared. Other one is color comparison. Based on that, we have two types: total radiation pyrometer and optical pyrometer. Now, total radiation pyrometer. The total radiation pyrometer gives a measure of temperature by evaluating the heat radiation emitted by a body. As we know, all the body whose temperature is above absolute zero will emit certain radiation. So, all radiation emitted by the hot body or a furnace are measured and calibrated for black body conditions, calibrated using black body condition. The total radiation pyrometer basically comprises an optical system that includes a lens, a mirror, and an adjustable eyepiece. The heat energy emitted from the hot body is focused by an optical system into the detector. So here we can see the system. Here we have the furnace or body whose temperature is to be measured. So it emits radiations. Temperature is above absolute zero. So this is focused by, first what we do is we align our instrument with this body, and this radiation focused by the lens to a mirror, and this mirror direct this radiation to a temperature detector, that is a thermopile or a thermocouple, which will give corresponding electrical output based on the temperature, based on this temperature. So that will be displayed as temperature with certain unit on the display device. So we have an eyepiece here, we have a mirror here, we have a lens here, this is the body, and this is a thermocouple or a thermopile which will act as the detector. That is, heat energy sensed by the detector, which may be a thermocouple or a thermopile, is converted to an analog electrical signal and can be read on a temperature display device. That is the principle. So here we have a radiation emitted by the hot body, and it is focused by the lens and directed towards a detector which will give electrical output, and that is converted to temperature reading on the display device. The pyrometer has to be aligned properly such that it is aligned with furnace or hot body and is placed as close to it as possible. This is essential to minimize the absorption of radiation by the atmosphere. The radiation pyrometer finds application in the measurement of temperature in corrosive environment and in the situation where physical contact is impossible. In addition, radiation of the moving target and invisible rays can also be measured here. In addition, radiation of moving target and invisible radiation can also be measured. It is also used for temperature measurement when the source under consideration have near black body condition. The advantages of radiation pyrometer: they are non-contact type, basic one, and give very quick response. High temperature measurement can also be accomplished this instrument. So this non-contact type, very quick response, and high temperature measurement can also be accomplished through this instrument. Then disadvantages: error in temperature measurement is possible due to emission of radiation to atmosphere. So some errors may occur. So that is about radiation or total radiation pyrometer. Now we are moving to another type of pyrometer, that is called optical pyrometer. Optical pyrometer work on the disappearing filament principle. Disappearing filament disappears. So disappearing filament principle. In order to measure temperature, the brightness generated by the radiation of the unknown source or hot body, whose temperature is to be determined, is compared with that of reference lamp. The brightness of the reference lamp can be adjusted so that its intensity is equal to the brightness of the hot body under consideration. Here, disappearing filament principle is applied. That's the first point. And the brightness of the radiation or light emitted by the hot body will be compared with the brightness of a lamp in our system or measuring system, and then by comparison we are measuring the temperature, and the brightness of the reference lamp can be adjustable with the help of a circuit by varying the current to the filament. So this current through the filament can be varied by using a rheostat, and here we have an ammeter to measure the current through the filament. So what we do is, here we have a light source or hot body whose temperature is to be measured. This is our system. So system consists of an objective lens, an absorption filter. Here we can see a lamp. This is the lamp, and lamp has certain circuit, an ammeter, a battery, and rheostat. By varying the rheostat, we can vary the resistance of the circuit, and the current can be varied. So by varying the rheostat, we can vary the brightness of the bulb or filament. Here we have an eyepiece to focus or direct or align this instrument with the hot body and to view or compare the light emitted by the bulb and the hot source. So that's about the construction of an optical pyrometer. The light intensity of the object depends upon its temperature irrespective of its wavelength. Light intensity depends upon the temperature. A battery supplies the current required for heating the filament. the current flowing through the filament is adjusted by means of a rheostat and an ammeter is used to measure it. The current passing through the circuit is proportional to the temperature of the unknown source. An optical pyrometer essentially consists of an eyepiece by means of which the filament and the sources are focused so that they appear superimposed. Both filament light and the hot body light, they are focused or superimposed, enabling a clear view of the observer for the observer. Between the eyepiece and the reference lab, a red filter is positioned, which helps narrows down the wavelength band and attain monochromatic condition. So we are keeping a red filter between source and the lamp. Between the eyepiece and the lamp to get a monochromatic condition. So the current in the reference lamp can be varied by operating the rheostat and can be measured using ammeter. Thus the intensity of lamp can be altered. So intensity of the light emitted from the lamp can be altered by changing the resistance of the rheostat. When current passed through the filament is very low, the radiation emitted by the filament is of lesser intensity. So this will be less than that of the source or the hot body, and the filament appears dark against a bright background. It will be observed as dark. When the current passed through a filament is correct, the intensity of radiation emitted by the filament is equal to that of source. So intensity of light by the filament and intensity of light emitted by the body will be same. Hence the filament disappears into the background. So it will be like this, it will disappear because both the intensities are same. It will appear, it will be disappeared. When the current passed to the filament is very high, the radiation emitted by the filament is of higher intensity than that of the source, and the filament appears brighter than the background. It will be like this. Compared to background, the filament will be brighter. So when the filament disappears, the current flows in the circuit is measured using ammeter. During this condition number B, the current through the ammeter is measured. The value at which filament disappear is the measure of temperature of the radiated light in the temperature source. So by calibrating it. So value at which filament disappears is a measure of temperature of the radiation light in the temperature source when calibrated. So that's the principle. So the light radiation emitted, intensity of light radiation emitted by the hot body is compared with the light radiation emitted by the filament, whose intensity can be varied by varying the current supplied to the filament. So up to a particular point, both the brightness matches. So then the current through the filament is measured using ammeter. That current is converted to temperature reading based on the calibration. So there are certain advantages for optical pyrometer and also some disadvantages. They are simple in construction and portable. The optical pyrometers are flexible and easy to operate. They provide very high accuracy. They are non-contact type. They are used for a variety of applications. They can be used for remote sensing applications, since the distance between the source and pyrometer does not affect the temperature measurement. Then optical pyrometer can be employed for both temperature measurement and for measuring wavelength that is less than 0.65 micrometer. Disadvantages of optical pyrometer. Optical pyrometer can be employed for measurement only if the minimum temperature is around 700 degrees Celsius. There is a minimum temperature for using optical pyrometer, that is 700 degrees Celsius, since it is based on intensity of light. Okay, so the temperature measurement A short interval is not possible. Temperature measurement at short intervals is not possible by this. The optical pyrometers are used for measurement of clean gases only. The optical pyrometer used for measurement of only for clean gases. That's about the disadvantages. Advantages, disadvantages. We found the principle and construction of optical pyrometer and total radiation pyrometer. Now we are moving to infrared thermometers. They are also a non-contact type thermometer. Every material or matter whose temperature is above absolute zero emit infrared radiation depending upon the temperature. The infrared radiation are invisible to human eye and can be sensed as heat. So infrared thermometer is a non-contact type sensor that can detect infrared radiation from a heated body. This is a detector, non-contact type, which can sense detect infrared radiation from a heated body. An infrared thermometer comprises a lens through which infrared waves is focused on the detector. So we can see the detector. The infrared energy is absorbed and converted into an electrical signal by the detector. So output will be electrical signal. The amount of radiation striking the detector determines the electrical output signal. The amount of radiation striking the detector determines the electrical output signals. The amplified electrical output signal is then displayed on the screen in terms of temperature unit. So amplified electrical output signal is then displayed as temperature on the screen. That is infrared thermometer. So infrared thermometer, we have a detector to detect the infrared radiation. So the output will be electrical. So that will be amplified to give temperature on the display device. So here we can see the image. So we have hot target. The radiation, infrared radiation is emitted, focused by light to a detector that will give electrical output, and that will be displayed as temperature in the display device. So that is about different temperature measuring instruments. So we discussed in this lecture, we discussed about resistance temperature detectors, where the principle is the temperature variation will result in the resistance variation, and for metals, as the temperature increases, resistance also increase. That principle applied for resistance or temperature measurement is RTD. And another temperature detector is thermistor, where semiconductors are used, where as the temperature increases, resistance decreases, but is having more sensitivity compared to RTDs. After that, we discussed about pyrometers. The pyrometers are used for non-contact type temperature measurements. And that's used for measuring the temperature of a furnace or hot body. They are of two types: optical pyrometer and total radiation pyrometer. Then we discussed about infrared thermometer, where every body emit infrared radiation that is converted to a detector, and the detector give electrical output. That electrical output is amplified and displayed as temperature on the display device. So that is about temperature measurement. So we have different temperature measurements. Okay. Thank you for listening.